to enhance our understanding of what we have just talked about. It says, calculate the mass of silver deposited when a current of 2.6 ampere is passed through a solution of silver salt for 70 minutes. Molar mass of silver is 108 and 1 Faraday is 96500 coulomb, 96,500 coulomb. Now, current, let's see. Current is equal to 2.6 ampere. Time is equal to 70 minutes. Is equal to 70 times 60 seconds, which is 4,400 seconds. And then we are told that the molar mass of silver is equal to 108 mg. Now, we have calculated, we have got to the time and the current. So, quantity of electricity is equal to 2.6 times 4,200 coulomb, which is 10,920 coulomb. And from here, we are asked to find the mass deposited. We know that 108 grams will be deposited by passage of 96,500 coulomb. Then n gram will be deposited by 10,920. So what does that imply? Since we are talking about the first Faraday law, we are talking about the same elements. It means that 108 over 96,500 will be equal to m over 10,920. So m will be equal to 108 times 10,920 over 96,500. So this gives me 12.22 grams. So what does that mean? It means that the passage of 2.6 ampere for 70 minutes will discharge 12.22 grams. 22 grams of silver will be discharged. So you can see. Since we are talking about the same elements, first law is applicable. So everything is still in direct proportional. Now let's look at another one to close it. Now let's look at this. It says calculate the volume of oxygen evolved at 285 Kelvin and 0.91 times 10 to the power 5 Newton per meter squared. When a current of 2.5 ampere is passed through acidified water for 1.5 minutes, molar volume of a gas is 22.4 GMP. Standard pressure is 1.01 times 10 to the power 5 Newton per meter squared. 1 Faraday is 96,500. Now let's look at it. Let's look at what happens at the electrode where oxygen is involved. You know, they say acidified water. So what happens? We have OH minus, and it's going to give us O2, H2O, E minus. That's how the reaction goes. And if we put 4 here, we are going to have this. How many H? So what happens now? We are going to have 4 electrons. So for us to have this, we will need 4 moles of electrons. That is 1. So which means that for 1 mole of oxygen to be evolved, we will need 4 times 9, 6,500 coulomb of electricity. That is what happens. Now let's quickly find out how many moles of oxygen will be given emphasize that it is the moles of electron that will determine how many Faraday that you will use. So, what does that mean? So it means that since 1 mole is 32.4 dm3, we need 4 times 96,500 kilometers. And so the volume under standard pressure, STP, standard temperature and pressure, discharge will be proportional to the quantity of electricity, which is 2.5 times how many minutes? 1.5 times 60. So this is the quantity of electricity that was passed through the acidified water. Therefore, for us to find V now, V at STP over 2.5 times 1.5 times 60 is equal to 2.4 over 4 times 96,500. Instead of trying to find how many moles of this one is discharged, let's really go straight to the volume discharge. So, we can now see V at STP will be equal to 22.4 times 2.5 times 1.5 times 60 divided by 4 times 96,500. Let me check this. 4 times 96,500. Now, the calculator will help us here. So here, we know that at STP, that is, when pressure is equal to 1.01 times 10 to the power 5 Newton per meter square, and temperature is equal to 273 Kelvin, V is equal to 0.0130570 dm. That is V. Now, we are now asked to calculate it when the temperature at T equals 285 and T equals 0.91 times 10 to the power 5 Newton per meter square. We have to find V. And we know the gas law. That is V, PV over T equals constant. We can now say that P1 V1 over T1 is equal to P2 V2 over T2. So we can now say that V2 that we are calculating is equal to P1 V1 over T1 times T2 over V2. And we know what our P's are. So, which is equal to, what is our P1? 1.01 times 10 to the power 5. No. This one is P2. What is our V1? 0.0130570. What's our T1? 273. What's our T2? 285. What's our P2? 0.91 times 10 to the power 5. So this one we can cancel this. We can now work it out using the calculator. So the answer is equal to 0.0151288 dm. Approximately 15.13 dm. So that is the volume at 285 Kelvin and 0.91 times 10 to the power 5 Newton per meter square. Now we have it. Calculate the amount of gold deposited when the current of 5 amperes passed through a solution of gold source for 2 hours 15 minutes. If the same current is used, find the time taken for 6 grams of gold to be deposited. This is a simple question. What we know is that AU is univalent. Univalent. Therefore, 96500 coulomb will liberate 1 mole or 197 grams of gold. Now, we are now told that 5 ampere is passed through a solution of gold salt for 2 hours 50 minutes. So let's calculate the quantity of electricity. We have Q to be equal to 5 times what is 2 hours, that is 120 plus 15 minutes times 50. So which will give us 5 times 60 times 125 coulomb. That is the coulomb we have. So let's now see. So 197 over 96500 will be equal to M over this 300 times 135. So mass discharge will be equal to 197 times 300 times 135 over 96500. And let's see. So this is going to give us approximately 82.68 grams. 82.68 grams. We are now asked, if the same current is passed, how long will it give us 6 grams? Since current is constant, I is constant. Mass discharge will be proportional to time. So we can now say that if 135 times 60 seconds give 82.68 grams, therefore T seconds will give 6 grams. So therefore we can now say that 82.68 over 135 times 60 is equal to 6 over 6 seconds. So C will be equal to 6 times 135 times 60 over 82.68. Let's see what that gives. So this gives us approximately 588 seconds. Almost 10 minutes. But I'd rather we stick to this. 588 seconds. A current is passed through 3 electrolytic cells connected in series, containing solutions of silver nitrate 5, copper 2 tetrahydrosulfate 6, and brine respectively. If 12.7 grams of copper are deposited in the second electrolytic cell, calculate A. The mass of silver deposited in the fourth cell. B. Volume of chlorine liberated in the third cell at 17 degrees Celsius and 800 mmHg pressure. We are told that Ag is 108, Cu 63.5, 1 Faraday 96500 coulomb, GMV of gases at STP is 22.4 dN3. Now let's look at it. Here we have silver salt. Okay, silver. This one we have copper. And this one we have Cl salt. Everything is series. And I believe this will make it clearer. Now, by the time you look at it, we realize that this is strictly where second law must be considered. And when you look at the second law, it talks about number of electrons as the valence electrons. Talk about moles and then valency. So it's after you have talked about mole, you now convert to the masses. Now let's look at it. If 1 mole of this this one, at the end of the day, we are going to have Cl, 2Cl minus to give us Cl and 2A minus. So what I'm trying to say is this. Please, I want you to see this one. This Cl now, I will need 2Cl minus to give me Cl gas. Now, let's check the number of moles of electrons that is needed for each to be liberated. Here I need 1E. Here I need 2E. Here I need 2E. You can see. So what does that imply? It means that when 1 mole of this is liberated, 1 mole of this is liberated, and 2 moles of this is liberated. You understand? So it means that any mole of this liberated, if X mole is liberated here, I have X mole liberated here, or so this one is 2.4 dm cube, or X times this. At STP, please. That's what I'm saying here. And this one, it means that it will be 2x moles. So it is this mole that we now convert to the masses or grams. So here is strictly about the second Faraday law. Or Faraday's second law, whatever we put it. Now let's look at it. It says, if 12.7 grams of copper are deposited in the second electrolytic cell, calculate the mass. So let's first of all calculate the mole of copper deposited. Will be equal to 12.7 divided by 63.5. And let's see what that gives. So this means 0.2 moles is given up, is deposited. So how many moles? Therefore, 2 times 0.2 moles of silver is deposited. Hence, mass of silver deposited will be equal to 2 times 0.2 times the molar mass of silver, which is 108. And that gives us 43.2 grams of silver deposited. So that gives us 43.2 grams of silver deposited. Now let's go to the second part. So we have seen that if 1 mole of this is discharged, 22.4 dm cube of this one will be liberated. Therefore, if 0.2 moles of Cu is discharged, therefore 0.2 moles of Cl2, please take note, Cl2 is liberated, which will be 0.2 times 2.4 dm cube at STP. So that's for this. But we are now told that the temperature is 17 degrees Celsius. Kelvin and 800 mmHg. We are asked to find what the volume will be at this condition. But at STP, volume now. So, using the gas law, you can say that V1 over T1 is equal to V2 over T2. So, V2 will be equal to V1 over T1 times T2 over T2. And this means that V2 will be equal to, what's our P1? 762. V1 is 0.2 times 2. Okay, let me see. So, you can calculate it now. To say V2 will be equal to 760 times 0.2 times 22.4 divided by 273 times 300 over 800. So this one can cancel. I also use this one to cancel this. This one can cancel. This one is 91. It also can cancel. Let's just use calculator. So you can see under the condition when temperature is 300 of 17 degrees Celsius and pressure is 800 mmHg, the volume discharges like okay, liberated is 4.677 Bn3. 0.222 gram of a divalent metal is deposited when a current of 0.45 ampere is passed through a solution of the salt for 25 minutes. Calculate the relative atomic mass of the metal. Now, just little proportion and consideration of the valency that you will need. Now, let's look at it. For a divalent metal, two times 96500 coulomb will be required to deposit 1 mole. And now we also told that 0.45 times 25 times 60 coulomb deposits 0.222 grams. Therefore, molar mass of it over 2 times 96500 is equal to 0.22 over 0.45 times 25 times 60. Since we are talking about the same metal, the mass discharge is proportional to the what's it called? The quantity of electricity. So that is N proportional to Q. Proportional to I. So that is what I did. So N, since this is constant, so N over Q is constant. So that's what I did here. Now, I can now calculate the molar mass. 0.222 times 2 times 96500 over 0.45 times 25 times 60. So, from the calculation, the relative atomic mass is 63.5 grams. Thank you if you have followed us so far. I appreciate your patience and your love for this channel. Kindly subscribe if you haven't. Share, comment, like, and follow in other channels. Please, if you have any question or you need any help on this subject, you can contact through the channels in the description below or through the comments. Thank you very much for assisting and for showing your love. I appreciate it. See you in the next lecture.